Watch this, it'll start again. I'll be so mad. Okay, so we're going to start a new project. Hello everybody at home. Which I will call simply 2D. Oh, it's back. I promise it didn't do that while you guys were gone. And just blank, we're not importing any packages for this one, so we'll just tell it to do its thing. Nope. What he's talking about is, I'll do it again. There was a checkbox you could have clicked. But I think it's more important that you know how to change it in Unity. So let's do a new project again. I should have changed setup defaults for 2D, but I didn't. Okay, so this time we're going to be working with 2D, and there's an easy toggle right here. You'll note that there's this 2D button here, and we can just click that, and it'll convert it to the 2D view. But if you want to set the default for the scene, you can change the default for the project by going up to Edit, Project Settings, and find Editor. And it's right here. So you can change the default if you don't set it when you create the project. Doesn't give you a lot because you can always, again, you can always just click this right here. It's a toggle, so you have to remember that. It's not going to change, it's not going to say 3D here. It probably should, but it doesn't. Okay, I'll put it back in 2D mode. And essentially what we're going to do is we're going to create a small animated character that can walk around and maybe run into a wall or two and pick up some objects. So just a really basic 2D. It could be converted into any kind of game that you want. And in order to accomplish that, we're going to be talking about Mecanum, or maybe it's Mechanim. I'm not sure how you say it. I'm going to say Mecanum. I'm just going to pick one and run with it. Which is their animation system, and their animation system is based on something called state machines. So let's do the state machine thing real quick to just get it out of the way. I'm just going to do this all in Wikipedia because Wikipedia knows everything. Okay, so there's two things to look up, because there's really two different ways that I'm going to show you to represent a state chart or a state machine. So first, let's look up Markov chains. These are quite a bit older, but they're very easy to understand, and I like them because they include probabilities on them, which makes them handy for game developers because a lot of what we do revolves around random numbers and probability. So they're pretty simple to read. This is not a stellar example of it, so I'm going to let you look this up and read up on Markov chains at your leisure. I'm going to change this to Markov chain weather because that one is very easy to read. If we go look at the images, there are going to be a couple of them that come up, and I'll just pick this one. And this one's pretty simple and straightforward to understand. We have two states in our Markov chain, sunny and rainy, and what these transitions are telling us is that if it's sunny, there's an 80% chance that tomorrow it will be sunny. If it's rainy, there's a 40% chance that tomorrow will be rainy. Oops, I went backwards. It's going back, so follow the arrow. This is called a transition. So this is how you move between states, and there's going to be some governing variable or thing that happens in the middle here that might change the state. So if you are rainy, there is a 60% chance, according to this Markov diagram, that tomorrow will be sunny, and a 20% chance that it will be rainy tomorrow. So that's really handy if you want to draw a Markov chain to represent how things are going to unfold in your game based on randomness. And like I said, very simple, easy to read. The other one is what the UML people are starting to adopt. There is no UML spec standard for state diagrams. But there is something called a Herald diagram, which I probably just misspelled. Maybe it's a Herald chart. Yes, thank you. 2 L's. And if we go look up at that, I should have looked that up on Wikipedia. Switch back over. Oh, not my night, is it? I love it. It'll eventually figure out what you meant. State diagram is what it really redirects to. Okay, same basic idea. This is what the UML people are starting to adopt. And this also is pretty straightforward and easy to figure out and read, but it doesn't include probabilities on it. So you might see one, both, or some combination. I would reiterate that the most important thing about a diagram is that it effectively communicates. So there is no Nazi police force is going to come knocking on your door saying you did the diagram wrong, as long as people can figure out what you meant. So this is also pretty easy to read. You also have 2 states, and here you're just talking about opening and closing a door. So you have an open state and a closed state. You have transitions just like you have in the Markov chain, except that this one lists the transition condition, and it also lists the action that occurs in order to get to that particular state. So if the door is closed, you have to go through the transition open door, you have to perform the action open door, and then the state becomes opened, which they've designated as 1 and 2 arbitrarily. So state diagrams and state machines aren't that hard to figure out. And one of the most important things to remember is that in C# we program with, we call it side effects, which means that as you change things in your program, you're changing properties, methods, and events. A lot of times, properties, methods, and events are going to be changed, fired, whatever, via side effects. When you do something, it will affect everything else in your program. That's called working with side effects. And the larger picture of all of that is called the state of the entire game. So you talk about state machines, you have to remember that your entire game is one big state machine. All of the variables inside of your program represent your program's state at any given time. Think of it this way: if you wanted to save out your game, you would save out all of the information that would allow you to reload that state later. So if you have a game with levels in it, you would save what level you're on. You would save what position your player is in. You would save which enemies are alive, which ones are dead. Any dropped items, their position might be saved, so that when you reload that game from your state, you can restore the game to what it was before the user quit. So that's probably the easiest and most intuitive way to think about the state of the game. And that's a really, really important thing to think about as you're developing your games. Alright, so let's start playing around with the 2D features. I've got a few assets for you. If you go to Blackboard and you find the Sprite Sheets entry at the bottom, and let's find, I'm sorry I did make that a link, but the first one, opengameart.org. Okay, so what this gets us, and go ahead and you want to pick the second one, the ping. I don't know if it accepts GIMP files as imports, but I know it accepts a ping. So I'm going to go Professor Walk Cycle, no hat. So what you're looking at is a sprite sheet. And this is the great thing about 2D work, is that you don't have to deal with geometry. You're just dealing with sprites. And what I like about this is I can be highly, highly detailed with no penalty. If you do high detailed geometry, you're going to incur the penalty for all those extra polygons. This is your way of using pre-rendered assets without incurring that penalty. And since that penalty doesn't exist, this is also ideal for mobile platforms which don't have the computing power to do lots and lots and lots of polygons with lots of lighting and lots of shading and all of that other stuff that goes with a really awesome 3D game.
And it would be easier to build as well?
I think it's easier to build, and I like the workflow better, and that's just me. I don't want to sound prejudiced because I'm not, but it seems like I'd be able to crank out a game faster doing it in 2D, unless it really had to, like a first-person shooter, obviously, I'm not going to be able to do that with sprites very easily. Not to say you couldn't, obviously, because that's what Doom is, but usually when I think of 2D work, I'm thinking of side-scrollers, I'm thinking of top-down adventures, stuff like that. Super Mario World, exactly. So those kinds of things.
You also do like a top-down or somewhat isometric?
Right. And that's what we're going to start with. This guy is obviously top-down. So we're just going to make a thing that allows him to walk in the 4 cardinal directions. So I'm going to save this. I'm just going to right-click it, save image as, and I'm just going to put it in my pictures folder because that's where I happen to keep all my stuff when I'm doing this kind of work. I usually throw it in one place when I download it, and then I just move it into Unity. Okay, I put it in pictures, and I'm going to just drag this and drop it into my assets. I don't have any folders set up or anything, so I'm just going to drop it in there. And when you're working in 2D, the very first thing you want to do is immediately click on that imported asset, and you want to come up here and look at all the properties that you're working with. First thing you want to make sure you check is the texture type. So it comes in as a sprite, and that's what you want, but sometimes it might come in as a texture. If it comes in as a texture, it's not going to work. You want to make sure it comes in as a sprite. Okay, the next thing you want to look at is sprite mode, single. Pretty obvious from looking at it that there's more than one thing on this sprite sheet. So if you had a single frame, you could leave it as single, but we're going to change this to multiple. And once we've done that, now we can go look at our sprite sheet and we can slice it up. Unity has all of the features that you need to slice your sprites internally as part of the application. So I'm going to click on the sprite editor. Now the trick here is you have to do this after changing it to multiple. If it's single and you open up the sprite editor, you're not going to be able to do this. You're going to be scratching your head, and it's just not going to work. I'll tell you what will happen. The slice button up here will be grayed out, and you won't be able to do anything. Okay, and it gives you this nice warning, automating sliced, compressed, blah, blah, blah. That's okay. Gives imperfect results. Now let me think about this for a minute, because I didn't see that before, but I suspect that I want to check this real quick. Let's check it anyway, just so you get in the habit of checking it. I'm going to close this for a minute before I slice it, and I really want to open this, but I have not set up my preferences yet, so let's remember how to do that. If you go up to Project Settings, Render Settings, I don't think it's in Project Settings, it's in Preferences. So if you select Edit and then Preferences, in the real world you only have to do this once. Click on External Tools, and the image application, it's set to open by file extension, so this might actually work, but I usually just go ahead and set this to Photoshop. Let's just see if it works by itself without any help. I should be able to double click. I'll probably be able to muddle my way through with Fireworks. I haven't used it in a while. You guys probably have though, right? Here's what I want to do. It'll open it up.
It says 2D slabs, usually GUI for sprite. Is that
There.
gonna be a problem.
Well, here's what I care about. I'm going to check the canvas or the image size. And the first thing I want to know is are both of these dimensions multiples of 4?
Yep.
And I think they are. 576 divided by 4 is 144, and 256 is as well. So that's fine.
Each sprite is 64 by 64.
Right. So you want this to be, you want the whole image to be multiples of 4. And this relates to the way Unity compresses images. So that works, that's not just with sprites, that's with any image that you import. You want the size of it to be a multiple of 4 so that it can do its magic compression. Okay, since I've verified that, now I'm confident that when I click Sprite Editor, I'm going to get something useful. So let's go up. I'll go up to Slice. It's up here in the corner. And there's 2 options for slicing. You can either go with Automatic or Grid. For this one, since I happen to know it was designed to be a grid, I'm going to click Grid. And I know that it's 64 by 64. I'm assuming that is, I don't think it's smart enough to look down here and figure that out. I think that's just the default. And I'm going to click Slice, and you can see what it does. It goes ahead and slices that out for you. And then the next thing you want to do is you want to come up here to this Apply button and click Apply. And now you're done. Pretty easy. Okay, so what did this do for us? If you go back down to Assets and look at it, you'll see that before there was no little triangle, and now there is. If you open up the little triangle, now you can see your slices. So our objective is to make the guy walk in the cardinal directions, and obviously that's what he's doing in our sprite sheet. And when we click on a sprite, we can see the individual pose for that particular sprite.
Make a delay.
Yeah. Yeah, we don't need the, well, we need the board later, but that's okay. Yeah, go ahead and hit it. We'll work around it. So as you kind of move down the list, you can see I'm just hitting the down arrow and the up arrow so that you can see what each sprite does. Okay, so we have him walking in all 4 cardinal directions. Okay, first thing we want to do is start making the various animations that will cause him to walk in those directions. Okay, so we're going to start at 0, and if I go down and look at 8, he's still walking north. At 9, he's not, so those are the ones that I want. So I'm going to click on 0, hold down Shift and click 8. I'm going to select those, and I'm going to drag them up into our scene. And it's going to prompt you for a new animation name. It's going to make the animation file for you. I'm going to call this Professor.
Oh, I'm stuck warping between that cursor and the European do not enter symbol.
I'm going to call this one Professor Walk North, and by default it's going to come up with .anim as the extension, which is correct. And I'm going to click Save. Bless you. And now we've got this little guy on the screen.
So tiny.
He is tiny.
Well, let me create an animation.
I'm going to move him over. So he's kind of in the middle. And next I'm going to click on my camera to make sure he's actually looking at the little guy. And he is. I can see him right there. Tiny little fella. Now when I click Run, he is actually walking. Very small. But he is actually walking. So that part is pretty straightforward to create the various sprites. So I've got an animation controlling those sprites. Next thing we're going to do is we're going to make the other ones. So start at 9 and go down. It's just count down 9. So it's 9, So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Check the next one. I'll come help you in just a second. Okay, so it's from 9 to 17. Drag that one out. That one is walk west. Sorry. And I'll let you go ahead and do the other two while I go help Marcus real quick. I call mine Professor Walk North. Doesn't matter if you do. There you go. He's right there. He's just little. Okay. So south is 18, 1, 2, 3, 4, 7, 8, 9, down to 26, I think. So that one is walk south, and the last one will be walk east. It's 3, 4, 5, 6, 7, 8, 9. Oops, that's east. Okay. So now I've got one for each direction.
You actually included the standing frames in the animation, which went actually quite a bit.
Yeah, that's okay. I mean, there's a lot of holes in this. We don't have any stills. We don't have anything like that. I'm just getting you through it. Okay, so at this point, we should actually have all 4 of them walking.
Oh, it's exciting.
I know, right?
Now we can line it. Burn it to the ground.
Okay, so this by itself would be enough for you to actually work with, because you could easily script something that just swaps out these assets, right? But that's not cool. That's not the cool way to do it. I'm going to close this up, and we can see what's going on here. Obviously, we created the animation files because that's what we named them. So those are the animation files. But what is this deal right here? These are the Mecanum files. That sounds like the name of a sci-fi show, I guess. It's like the X-Files, but Mecanum, no, I guess not. I'll work on it. So these are the state machine files that got created automatically as well. So instead of having 4 state machines, what we really want is 1 state machine that controls all of them. So what I'm going to do is I'm just going to pick one, and I like the one, let's see, which is the one that's where he's walking towards me. I think that's that. Yeah, that one. Okay, so I'm going to spread this over a little bit. So this one is called Professor Walk Cycle No Hat 18. And I can see that it has an animator. I'm saying the tor on purpose because there's 2 parts to this. There's an animator and an animation. And even windows to get them confused. So we have an animation window and an animator window. And make sure they do completely different things. So we got to make sure we know what we're talking about. Okay, so I'm going to use this one. I'm going to pick the Professor Walk Cycle No Hat 18, and I'm going to simplify this name to just Professor. And the controller is Professor Walk Cycle No Hat 18, so I'm going to click that one, and just so I know which one it is, and now I can get rid of the other ones that I don't need. So I can get rid of,
So the animator controller.
yes. So I don't need No Hat 0, 9, and 27. So I can get rid of those. Okay, let's pick on our Professor Walk Cycle No Hat 18 Animator, and let's open up the Animator window. I promise I won't say it that way from now on. Go to Window, Animator. Let's see if I can move these out a little bit.
Look, there's a business.
Apparently not by very much. All right, that's fine. This is not going to be a very detailed state machine. All right, so automatically you get a few states. Automatically you get this thing called any state, which I'm not actually even going to use, so I'm just going to move it up here out of the way. And then I've got this other one called Professor Walk South, which is the animation that I picked. Remember, I had 4 of them up there. That I happened to pick this one. That one is animation Walk South. And so it's orange because that's the default state. So what we're going to do is we're going to make some more states. That's pretty easy. Incidentally, this is super easy in 2D. It's a little more involved when you're working with 3D, but there's a workflow for each. So I'm going to select Create State, Create Empty, and I will call this one Professor Walk North. And I will populate its motion field right here with Professor Walk North, the animation. So I'm just going to click this, drag it, and drop it right here. Alternatively, you can click this little target thingy and pick it from the list, whichever you are more comfortable with.
And we create 2 more entities.
That is correct. And I will set it up visually, though it doesn't have to be. But it just makes sense to do that. So this one's going to be Professor Walk West. Populate that one with Professor Walk West, the animation, and do the same for the other one. Oops, I should be consistent. Walk east. You can put spaces in there if you want to. I just don't. And that one is Walk East. Okay, so thinking back to our state chart diagrams, we now have 4 states. Now we're going to need transitions to move between the states. So to do that, I'm going to right click, select Make Transition, and it's just drawing an arrow. So here's what you need to be thinking with respect to your transitions. Is there a way, should there be a way, to get from this state to this state? Yes. And as it happens, the answer is going to be yes for everything. You should be able to, when you're walking south, you should be able to turn and walk east. You should be able to turn and walk west. You should be able to turn and walk north. So you can draw transitions to each of these.
Now, does it go both ways? Or do you have to draw arrows from each one to the other?
Well, which part of that question should I answer first? Does it go both ways logically? Yes, of course. If you're walking north, you should be able to walk south.
The transitions.
But when you make the transition, you do have to draw both of them.
Okay. That was the one I was at.
Well, I like to be thorough.
Mm-hmm.
Okay, I'm not going to draw all of them. I'm just going to draw the first 6.
If you're walking west, you can't go east. Makes sense.
Nah, the heck with it. Let's draw all of them. Okay, now we've got all of them. That is a state chart extraordinaire. Except it doesn't do very much right now, right? It just shows what's possible. So now we need a way to manipulate our states. Gonna have to look at my notes because I forget which one is which. You'll see what I mean here in just a minute. Acrobat. There it is. Why won't you open? There it is. All right. Tell you what. For the folks listening at home, we'll put it on the screen. All right, I'm going to designate the directions as numbers. And let me go look at what I have. 1, 2, 3, and 0, 1, 2, and 3. That's right. That's right.
Will Notepad++ work here as well?
Yeah, I'm just throwing something up on the screen so the people that are watching at home can see it. It wouldn't do to write it on the board because they can't see that. Okay, so we're going to do 0 for south, 1 for west, 2 for north, and 3 for east. So that'll be our convention. Okay, that has nothing to do with the code. I just put that up so that you can see it on the screen capture. Okay, in order to make our little strategy work, what we're going to need is a parameter. So let's come down here to parameters, click the plus sign, and we're going to create a new integer to store our direction. And I'm just going to call it direction and leave its default value at 0, which, as you recall, is south, which happens to be what I picked as the default state. How about that?
And that would make D1?
You don't actually have to make them. You don't have to make one for north, south, east, and west. What you do have to do, and this is a little bit tedious, is you have to change each one of these transitions. So let's click on this transition right here. And let me see if I can scroll this over a little bit so you can see everything a little bit better. So you can see the transition taking place here. This is what this is showing you. And you can watch him down here. What's your question?
I don't have a parameter.
It's not here, or you just can't see it?
It's not.
That's weird. Okay. So I'm going to click that first transition. And you can see down here what the transition's going to do. Yes. Which of course you can adjust. So you can just kind of play with it until it makes visual sense to you. And now you can see as you transition what that transition's going to look like. The part that we really want to focus on, though, is this part right here that says conditions. So by default, it's going to have exit time equal to 1 second, which is totally not even close to what we want. It knows that this is an animation, and it just assumes that you're going to change states when the animation is over after 1 second, which is kind of silly because that animation isn't a second long by a long shot. It's quite a bit shorter than that. So I'm going to change the condition to direction. Now it's going to have a list of all of the parameters that you've created for this state machine. So that's where it's coming from. It's literally coming from right here. If you add more parameters, you're going to see them in the conditions drop down. So I'm going to select direction. Select your qualifier, greater than, less than, equals, or not equals. We're going to stick with equals. And here we're transitioning from south to what? East?
So equals 3.
And east is 3. I'll take your word for it. Sounds right. Okay. And now you know what to do for the rest. Just go through for each one and change direction to whatever appropriate number. That one happens to be 0, so I don't have to do anything else for that one. Okay, so from west to south, it's also going to be 0. South to west is 1. Okay, this is west, north to west, so west again is 1. North is 2. East is 3. North is 2. Oops. West is 1. Just like the movie. That was pretty funny. How the West was 1. Ha ha ha. North is 2. Last but not least, south is 0. Okay, quick check. I'm just going to go through real quick and click on each one of them, make sure none of them actually still says exit time on them. Make sure I didn't miss anything. And I didn't. Okay. Now would be a good time to save the scene. And now let's take a look. Let's switch back over to our... Actually, let's just run it. And we can see our little guy there. The others shouldn't be walking anymore because we deleted their controllers. But your little guy here is walking now. I'm going to peel this off so it's by itself. if I can put it somewhere without it docking. And then I'm going to switch over to the animator window, and I can see our state machine in action. So this little bar here is indicating that that state is what's currently firing. And if I change my value here on direction to say 2, which is north, he should transition into that state, and now you can see that that state is active. Likewise, I can press 1 and he will walk west. I can press 3 and he will walk east.
Where are you changing that?
In the parameter itself down here at the bottom. So you can set these to whatever you like and see how it's going to look when you're actually running it. Everybody good? Who says Mechanum's hard? Mechanum is not hard. Unfortunately, Unity's very first Mechanum tutorial was horribly hard. Horribly difficult, I should say. So a lot of people got put off from using it. In fact, there are even add-ins on the asset store that allow you to not use Mechanum. The thing about that is that that's a bad strategy, because this is what everything is moving to. We said earlier that there are 2 windows here. There's Animator and Animation. The animation window is eventually going to go away. They consider that the legacy system. So if you see anything mentioning or talking about the legacy animation system, that's what it's talking about. Everything is going to use Mechanum eventually. Maybe as soon as 5, I don't know what their plans are for moving this feature out. But they seem to be pretty aggressive, considering they completely got rid of all the old UI code stuff. It still works if you have an older piece that uses the old UI constructs. It still runs, but the menu items for creating new ones are gone. And that's kind of how I would expect this to be phased out, the animation stuff. We'll look at animation another time, maybe tonight, I don't know. It depends on how far we get, but we'll look at the animation thing separately. So pretty good. Everybody got your states working? Everybody's good? Let's switch back over to the scene view. I'm going to zoom in on it because I'm tired of looking at the tiny guy.
Do we delete the other ones?
Yes, you can. Just make sure you don't delete the wrong thing. So you can delete them from the hierarchy, and that's safe. That's a good looking professor with his tie on. That's pretty cool. His leather jacket and his flashlight. Alright, that's neat and all, but now we need to actually do something script-wise so that we can make this respond to input. Okay. So I'm going to add a script component to do just that. New script. I'm going to call it character controller. Make sure you change the language to C#.
Is it a component? Oh.
Yes. And I'll click create and add, and we'll see it added right there. I'll double click it to open it. So the whole point of this script is going to be to move our player around. So I'll just make a little notation of that at the top in lieu of whiteboarding. And I'll make this a little bigger so we can see.
This would be pretty simple to do, right?
It is very simple to do. This is not going to be a horribly complicated script.
You get the input and then change the what the what do you call that?
Well, let's just do it. How's that?
Okay. The direction thing be considered a variable?
I don't use it as such because it's on the animation state. So we don't need to make a separate variable for it. Okay. We're going to need a reference to the animator component. Now remember, this script is on the object, right? We've attached it. It's part of this object right here. So the object in question contains the sprite, the renderer, the animator with the state machine on it, and this script. So it's all one object. So we can use that little trick that we used earlier to get the animator component, because as I mentioned earlier, there can be only one animator component on there. It's like Highlander. There can be only one. That was pretty good. That was a pretty good impression. That's another movie y'all need to see. It's pretty good. It is my second favorite movie of all time. Love that movie. Don't bother with which one was horrible. The second one? I think all of this. There was one that didn't really make me mad. The one with the skateboards just made me mad. The rocket-powered skateboards. That was a bit too much.
Did you pull out the band
But
hammer?
the first one was really awesome.
Did you whip out the band hammer?
Something like that. Okay. I want a reference to this animator component, so I'm going to create a variable. Should it be public, private, internal, or protected? I don't need it in the inspector. Private. Okay, I'm going to start doing this because everybody does this. I don't like teaching you to write when you're brand new at this stuff. Animator, the name of the variable is the same as the class, but since it's all over the place in Unity anyway, you might as well get used to it now. I would normally be very careful to name it something besides animator, but let's just rip off this band-aid and get used to it. So my animator, little a, is an instance of, or will be an instance of, the animator class, big A. Just remember that they're not the same thing. And I will initialize it, since I don't have a constructor, I'll initialize it in start. I could have a constructor if I wanted to make one, but it is the Unity way to do these things in the start method. So I'll set animator equal to, now earlier I've shown you a couple of different ways to get components, right, or get at objects. We've looked at find objects with tag. We've gotten it off of a collider. This is a lot of what you do, is finding a reference to the thing that you want. This is another big one that you're going to use all the time. If you're looking for something that is attached to the object that you're dealing with, which is the case here, we want the animator component that is attached to this object. So we essentially want a reference to the animator component itself. We already have the object because we're in the object. There's a parent-child relationship between these things. So the game object that we have, we want to get the component, singular, since there's only one, of type animator. Do you remember what the angle brackets mean? That means it's specifying the type. It's called a generic in C#. So the get component method will return whatever you ask it for. but you have to tell it what type you're wanting. So it will go down, it will find the animator component. Since there can be only one, it's going to return that one. If that component is not there, you're going to get a null reference exception. It's not going to be pretty. There is a way that you can ensure that there is an animator component on there, but I don't remember what it is off the top of my head, so I'd have to look that up. Not part of this exercise. I'll remember it for next time, though. Okay, so now we've got the animator, which means we now have access to the states and all of the things that we created a moment ago. So let's go ahead and get the input data from the keyboard, or it's the input access. I'll show you what that means in just a minute, or I'll remind you. I'll set vertical equal to input.get access vertical, and I'll get the horizontal. Make sure you spell it correctly. He says as he spells it with an X.
Okay.
Okay, gentle reminder as to where vertical and horizontal as string literals are coming from. We call it a string literal when we hard code a string in here. If I go back into Unity and I go into Edit, Project Settings, Input, you're expecting a dialog box, but you will not get one. It simply changes this area over here. And there's this nifty little thing that says axes. Let's open that up, and you'll see all of the different axes. These are the control axes that are available to you. And you'll see there are two, horizontal and vertical. And you can see that those are named horizontal and vertical. You can change those if you want. You can name them whatever you'd like. I've never had a reason to change them, but if you were keen on changing them, you could. The other thing that it will specify is what triggers them. So negative and positive, these things will return a value between -1 and 1. So usually with a keyboard, it's always going to be -1 or 1 or 0 if no button is being pressed. But if you have a pressure-sensitive joystick, this isn't limited to just keyboard input. You can see as you come down here, you've got joystick numbers, you've got different things like accelerometers. There's all these different axes types and input device types that you can get, which may render fractional amounts. So if you're playing with your Xbox 360 controller, you can jam that thumb controller hard over to the left, or you can just give it a tiny, tiny little push and it's not fully over to the left. You're going to get a magnitude smaller than -1 or 1, whichever direction you're pushing it. But since it's a keyboard, it's always, for us, it's always going to be a whole number, since you can't partially press a key on the keyboard. But I wanted to remind you that that's where they're coming from. You can change them, but anytime you see a hard-coded value, you need to understand where that's coming from. So there's your refresher. I'll switch back to the code. Now we know where that is.
How did you get that window on the right, that information?
It's Edit, Project Settings, Input.
Thank you.
And it always confuses me because I expect a box to pop up, and if you're staring at the screen, you just get this over here, and it's even closed up, so it looks like nothing happened.
Thank you.
Yeah. Okay. So now we've got our numbers for horizontal and vertical. And now we're just going to make our guy face. We're going to start off just making him face whichever direction he's supposed to. So I'm going to say if vertical is greater than 0, and I'm going to make a notation here because I will not remember. If it's greater than 0, then he's facing north. Okay, we've got our reference to our animator, so I'm going to say animator. Oh, careful. If you just hit tab, you're going to get big A, and that's going to be a pain. Make sure it's little a. Okay, now if you might be expecting to find direction here. A true C# programmer would, but that's not how this works. It doesn't actually introspect and find what's in the animator component. That would be cool, but it doesn't do that. So you have to send it a message through a more generic way, and the way they do it is through the set methods. And if you remember, when we created that parameter, we were allowed to create a Boolean, a float, an integer, a string, or a trigger. Those were your options. And it looks like there's a few other things in here that you can't set, which do other things that we are not concerned with right now. We're going to set the integer. Since that's the kind of parameter that we created, we have to tell it the name of that parameter, which is direction. And then which one is north? I'm going to have to go look. North is 2. Am I looking at the right thing? Let's see here. Yeah, 2. Okay. Whoops. Let me clean this up because I can't stand this. Drives me crazy. I know, short trip, right? There we go. Incidentally, if you didn't know this, tab, if you select multiple lines, tab will move it over. Shift tab will move it backwards. So you can clean that up a little bit. That's what it's supposed to look like. Alright, you might be tempted to type else here, but that would be wrong. Ooh. If you just type else, then you're going to get into a bad little situation here. He's going to be facing south unless you tell him otherwise. That's not really what we want. So I'm going to change this. Instead of an else, I'm going to do an else if. I'm not a huge fan of else if, but in this case, it's the right thing to do. Yeah, I see it. Thank you. I misspelled. Yes, it will. That's why it's red. The Marines say that pain is just weakness leaving your body. Set integer, direction, and this one's going to be 0 because it's south. And it messed everything up again. I'll fix it in a minute. I'm more interested in whether or not it's working. And it isn't. Let me see. Why not? We did vertical, up and down, set integer. Oh, why it's not working? Direction. Good. Maybe it is, and it's just too small, and I can't see it. No? I've typed something wrong. That's okay. I can always switch back to my scene. Whoops. That's not a good idea, is it? Oh, there it goes. I don't know what I did wrong, but it's working correctly, which is good because I didn't see anything wrong with the code. Yeah. Or I didn't have the, this probably didn't have focus. Yeah, see, if you're not, you got to click in the game window to give it focus so that it'll work. If you've focused on something else, Unity has focus now for up and down arrow. So it's not going to work. So make sure you click in the game window and make sure that works. Okay, that's pretty cool. But I told you at some point, I don't remember when, but I know I told you at some point, that this is a really bad idea. Because nobody but nobody is going to continue to remember 0, 1, 2, 3, and 4 for directions. Do you remember the construct that we created to make that better? Do you remember what it's called? Starts with an E. Whoops, didn't mean to do that.
Numerator?
Can you make it go backwards?
Yes. You just select multiple lines and Shift Tab will move it backwards. Okay, let's make an enumeration. You were close. You said enumerator. It's enumeration. You said enumerator because we did that earlier.
Oh,
I'm giving you the benefit of the doubt.
thank you.
I'm erring on the side of brilliance here. I'm just going to close that because I don't need it anymore. Okay. I'm going to make my enumeration outside of my class so that it is visible everywhere. In the grand scheme of things, I might even put this in its own file. But for our purposes, it will be fine since this is the entirety of our script. It'll be okay. So I'm going to create public enum. And now I have to get the order right. So south is 0. West is 1. North is 2. And east is 3. I don't need a thing there, do I? I don't think I need a thing there. Okay, it goes away eventually. Okay, now I can come down here. Oh, I didn't give it a name. That's why it's mad. How about we say directions?
Those need to be curly.
Yes. Enum is kind of up there with class. So enum, class, interface, those can all be top level. I could have put it inside my class. For that matter, I can put a class inside of my class. I don't recommend it, but you can do it. There's some places where that's just the thing to do. But I'll leave it out here. That way it's accessible everywhere. And it's just directions. If I put it inside, it would be character controller dot directions dot, and that would be weird if you were somewhere else. Okay, so now I can come down here and change this to directions dot north. Better, right? Except it's not going to work. Spoiler alert. It is going to break. I'll come up here and click build, and I'll pick build assembly C#, and it's going to tell me that the best overloaded method, blah 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 blah. It's not going to work. Has some invalid arguments. So it's looking for string and int. Now technically, it really should work because these are integers. They should evaluate as integers, but they don't. When you create an enum in C#, it actually creates a user-defined type. So it resolves as type directions, not an integer. What's that trick we did earlier? What's that thing called where we change the type? Casting, that's right. Ooh. Let's cast this bad boy. Now earlier I showed you the, what did I use before? I used the convert? No, I used the parse. There's a couple ways you can do it. You can use convert, you can use parse. I can show you convert, but it won't work, so don't bother typing it. Convert looks like this. And it's not showing up because we don't have system in here. So I'll do using system. And now I can do convert to, and there you go. So we have this convert case with all of these conversion types in it. And you'd have to guess, is it a 16 or a 32 or a 64? I'm not sure what byte size it is because it just says int. Int 32 would be a safe guess. So the convert function would look like this, except I already know that's not going to work because I tried it earlier and it didn't work. Oh, it did work. But the other way to do it, I hate it when that happens. The other way to do it, and this is a little easier, is just to put int in front of it like that in parentheses. And that does work. So you're going to see that a lot. That's a very popular way of sort of implicitly telling it what type it's going to be. And it assumes that that conversion is legal, which of course it is. So let's try it again and make sure it still works. Yep. So up and down still functions. Why don't we do left and right? Almost the same code. Alright, it's greater than 0. Animator. Oops. I did it again, almost. Just got to keep an eye out. Set integer. Direction. Int. Directions. Dot. And what would it be? West, right? Well, if it's wrong, we'll figure it out pretty quickly.
Positive is east, I think.
Like I said, if it's wrong, it'll be really obvious. That's a very shallow bug. Else if horizontal less than 0, animator dot set integer direction int directions, and we did east before, so this one must be west. Alright, ugly but functional. Let's see if it works. Yep. Up, down, left, right. You can also do W, A, S, and D, because those are set up as alternate keys in that dialog that I showed you earlier, the input configuration. Very important that you accommodate your left and right-handed players. Okay. Let me clean this up a little bit. Fix my incorrect thingy there. And make sure this is west. So primitive. In Visual Studio, I have a hotkey. Done. Alright, one more thing, and then we can get him to move. Getting him to move is actually pretty easy. There's 3 ways to make something move in Unity. You can modify its transform. You can apply force to its rigid body if it has one. This one doesn't have one, so we couldn't do that. So if you remember in the marble game that you created, you added force. The advantage of that is that when you added force, you caused your marble in that marble game to roll. When you move transform, it's not going to do that. It's just going to physically move it from one place to another. Sort of like teleportation, 1 pixel at a time.
Is that a marble game?
You did in intro. If you took intro with Kura and you did it recently, you may not have. You may not have taken that class.
I didn't really do the marble game.
I'm sorry?
I said I really didn't do the marble game. I did something else.
Well, if you're interested in doing the marble game, it's a good learning experience, and it's on the Unity website. Real simple. So if you didn't get a chance to do it, you should try it out. Okay, and then the third one is a funny word, which we're gonna cover at some point, not tonight, but some point soon. It's called lerping, which is an interpretation function that allows you to figure out the distance between two three-dimensional points and move a certain distance between those 2 points. This gives you the advantage of being able to do non-linear movements. So you can curve, you can start off slow, build up to a faster speed, and then come to a stop. So if you're doing a car, imagine that it starts off slow, it accelerates, it reaches a maximum speed, and then it decelerates as it reaches its final destination. Lerping will allow you to do that because you have more mathematical control over the function's return values. So that's for another time. When we make Frogger, we're going to need that, but not for this one. We're just going to do the simplest one for this one. And we're going to change its transformation, or its position. Both of those are true. The position is part of the transform. So more specifically, transformed opposition. Very simple. You cannot change the transform directly. So you have to do it in 2 steps. I'll create a variable called move, and I'll create a new vector 3, which is just 3 points. That might seem counterintuitive since we're in 2 dimensions, but we're going to use a vector 3, and we're just not going to use the 3rd dimension. So to do this, I'll say input get axis, just like I did before. In fact, no, why don't we just use, I've already got it. Vertical. And nope, sorry, I got it backwards. It's horizontal for X, right? Vertical for Y, and 0. So we're just not using the Z, it's always going to be 0. Okay, and now we're going to change the transform dot position. We're going to add to it by whatever the value of move is. Now, we did this last time, right? What was wrong with it? It was horribly slow, right? We did it with a rotation. So we need to speed this up a little bit. So let's go up to the very top where our variables are, and let's create a public one called move speed. And I'll set it equal to 5 as a default. Why did I make that one public? Oh, I got to give it a type, don't I? It's an integer. How come public? So I can change it, exactly. Ooh, that's not good. Did I put it in the wrong place? No, public int move speed. Okay, what's your problem? Oh, I forgot the new keyword. Fabulous. That would have worked fine in JavaScript, but in C# you got to put new in there. Okay, so if I go back and look, having made that change, I should see move speed 5 over here. That's probably exactly about what I want it to be. Actually, that's still going to be pretty slow. That's okay. We'll multiply it. So move times move speed times time dot delta time. What is that? We covered that last time.
Time since last frame.
Exactly. The practical use of it is that it will make your movement not jerky. If your frames vary in length, then this will accommodate that. Okay, let's give her a whirl. And we should now be able to see him walking. Probably won't match the animation very well. That's the artist's problem, right? But he is moving. Nifty. There's probably a little bit of that going on.
Okay.
But he's going to reach that terminal velocity pretty quickly, and there's no way to make it, say, half of that speed like you would if you had a gamepad. But since it's happening 60 frames a second, the acceleration isn't instantaneous. Should be pretty quick, though. Bless you.
Excuse me, thank you.
Okay. We don't have time to do everything I wanted to do tonight, but we're pretty close. So I'm going to show you something else that I think you're going to like. And it's not even in Unity. So find Flash. I'm assuming you all have Flash on your machines, right? So normally my next step would be to create a wall that he can't walk through. But that's pretty easy. You just make some bricks, like a brick wall in Photoshop, bring it in, and give it a collider. To make all of that work, though, you're going to have to do a few things to this guy first. You're going to need to add, I'll go ahead and do this part, we'll add a physics 2D. So this is the trick to this, is a physics 2D, and I'll add a box collider to him. And if I had more time, well, let's see if we can do this really quick. We want to change the size of it a little bit so that it matches his size a little bit. And you could tweak that.
So you can also like lean against the wall or something?
Right, so you can tweak that. You wouldn't want a collision detected here because that's not a collision, right? You want a collision detected on the actual guy. So you can fiddle around with the size and the shape of it until it matches him.
How do you make the box collider 2D?
When you add it, when you click Add Component, it's under Physics 2D.
Oh.
Not Physics, Physics 2D. So here's another spoiler for you. I would normally make a cylinder. It's legal to mix 2D and 3D content. And then I would walk you through the exercise of making the collider and all of that. I'll just cut to the chase. You can't do it. The physics engines for 2D and 3D don't interact in any way, shape, or form. So you can't have a 2D collider interact with a 3D collider and expect it to work. They just don't. They're not compatible with each other. Nor can you put a 2D collider on a 3D object. That doesn't work either. So there you go. I saved you some time. Okay, so I've got my collider on here. I'm also going to add physics 2D, and I'm going to put a rigid body on him. Now the trick to this one is, since this is a top-down, we don't want gravity to affect him. On the 3D rigid body, that's a checkbox, but on the 2D one, it's a number. So gravity scale, you want to set that to 0. If you don't, he'll fall as soon as you turn the game on. That's not cool. Okay, so the next thing I was going to have you do is make a coin for him to collect. So I'm going to do this. I'm going to go fast. If you can't keep up, remember I'm recording. Hopefully it's working. But there's a really nice feature in here, and I'm not going to make an artistic masterpiece. I'm just going to make something real simple. But I'm not going to make it blue. And I'll give it a stroke color of black.
Oh, you have to like click on the pen.
Yeah.
Okay.
Got to get rid of this first.
Go under fill and stroke.
I'm just going to stick with whatever's default, which is 1 pixel. Not terrific, but good enough. Okay. I'll pick my circle. I need to make this into a movie clip. I'll call it spinning coin. Registration in the middle, please. And now I'll go in here and I'll edit this guy. I'll take it out to 15. I'll add a keyframe. And I will squash him. And I could make this a 3D object to make it actually spin.
Actually, wait, before you do that, go back. Like, don't change it yet. Maybe you should make another keyframe.
It's okay, I know what I'm doing. Okay, good enough for government work. Now I need to shape tween this. So now I've got like the world's cheesiest flip, right? Now I just need to ping pong it. I'll copy that frame, paste it on 30. It's gonna be a long flip, right? Paste it, do it again. And now I've got a nice fast ping pong animation, right? Here's the cool part. Okay, that's like the most boring thing you've ever seen, right? Save as, just in case I need it again. Okay, I'm gonna go in the library. Watch this. Right click. Oh, looky there. Generate sprite sheet. Look at that.
Whoa.
Export it. Oops, I wasn't paying attention to where I put it. Shame on me. I'll do it again. I'll put it in pictures so I can find it. There it is. Now I'll bring it in. This one we would auto slice. If I can find it again. There we go. So I'll bring that in. Do the same thing we did before. Make it a multiple. Go to the sprite editor. These are not uniform in size, but that's okay. I'm just going to automatically slice it because this one isn't really as important with respect to where the registration points are. This is just going to sit there and spin.
You mean animation in Flash?
Mm-hmm. Export it as a sprite sheet. And did I click apply yet? I must have forgotten to click apply. Slice, apply. There we go. And now the thing is there. I can grab these guys. I don't need this anymore. And I put a coin out. There we go. It's ginormous. That's okay. Let me scale it down. And there you go. There's your spinning coin. Oh, that's not good. We got a glitch. Again, blame the artist. Dirty low-down artists.
There's a glitch in the matrix.
Exactly. Folie à deux. Alright, that's not going to deter me though. I'm going to click this guy. I'm going to add Physics 2D. That's the watchword from now on. It's got a collider. I'll make it a trigger. And now I'll add a script, which I'll cleverly name coin controller. And now we have everything we need. So if I want to make this guy collect the coin, I will say, now here's another trick. Remember, 2D, everything is 2D. The function names are different. So I'll say void on trigger enter. Okay, that's for 3D, but this is 2D. So it's 2D. I could give it a collider, but I'm not going to. I'm just going to say destroy game object. Little g. Okay, if everything went well, I should be able to run into it and it should go away. So now I've got a nice coin collector. Naturally, I would want to do more. I would want to have it give me a score and all of that neat stuff, but that's pretty easy to figure out. If I really wanted to do this all out, since I have a few minutes left, I really should tag this as player. That way, if you have enemies, they're not going to collect the coins. That would be no good. So we'll give this Collider 2D. It might make an interesting, different approach to the game, right? If they're trying to get them before you. Okay, same trick as before. Oh. Other dot game object dot tag equals player. Whoops. Then it'll destroy it. Pretty nifty. The only other thing that I didn't show you in the few minutes that I have left, now that I have two things on the screen I can show you. In 2D, we never did this trick. This is something out of that last Indiana Jones film, right? You can click 2D and look at it from the side, and you can see if things are lined up correctly. This is useful if you have a 3D object in here. But the other thing that you can do is you need to be able to use the layering system in here. So these two things are on the same layer, but what if we didn't really want them to be? What if you wanted a background that would move independently or be animated independently of everything else? And we have something for that called sorting layers, which they crammed conveniently in here with regular layers. So if you come down here, you won't see them. You click Edit Layers, and now you can see they've added. Ooh. Sorry, people at home. I just knocked you over. Sorting layers. So you open that up, and this is just like layers, except it's two-dimensional, and it allows you to configure, just like in Photoshop, what appears over what. So right now there's just one. Let me get this out of the way. I'll add a layer called player, and I'll add a layer called coins. And ideally I would have one for the background. I'll go ahead and make it. Maybe I can whip the graphic up real quick. Probably not. Okay, so 3 sorting layers. Let me see if I have anything I can use. How about a chrysanthemum? Nice. Alright. Here's my chrysanthemum. Okay, I'm going to make that on the sorting layer, which is not here. That's confusing, right? You want to go up here and set the tag. It's actually on sprites. You change it here where it says sorting layer, and we'll change that to background, and we'll change our guy, which we can't see right now. We'll set his sorting layer to player, and now we need to check our layering. So let's go back into layers. Sorting layer default, player. Okay, so edit layers, and you can just change these by dragging them around. Easy peasy, right? So that's the layer part. So that's it. Remember, next week there is no class. I will be in Florida at an undisclosed location. Wow.
What are you doing there?
Can't tell you. It's a secret. What else was I going to tell you? Oh, for next week, what you can do is I'll put some stuff up for you to do over the week, but
Our GDD and the interview.
oh yeah, you have your stuff, your due stuff, but in lieu of next week's lecture, you really should go review, in addition to whatever I put up, the 2D tutorial material. Now this is not the same as the exercises. It's just kind of like a movie that you watch. It's not an exercise. So it's here, and if we go to tutorials, It's not a project, but it's in here as 2D. And just watch those videos. And then the other thing that I recommend that you do, just so you can kind of get a heads up on where things are heading with the UI, there is a tutorial in here for the new UI stuff, and it's, I think the only time you can get to it is on this thing. There it is.
I'm much more interested in 2D projects than 3D.
Yeah, that's where I'm focused right now too. I'm doing all of my work in 2D. That's just how it turned out. So check these out because it's completely different than the old way. Here's the unfortunate part of this. They have not shipped Unity 4.6 yet. In fact, they're several months behind schedule. So you can get the beta, you can play with it, you can do all this stuff, but there's absolutely no telling when they're actually going to release it. So if you wanted to actually build a game and release it this month, you wouldn't be able to do that. Because it is a beta, it's going to show up all over the place. It's going to say beta, 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 and there are going to be things that aren't working or fully tested yet, specifically with regards to the web player. That seems like the last thing they always do is the web player. So be aware of that. On this, by the same token, though, I have this. This is what's on my laptop. So if you want to use the new features and make games and stuff like that to turn in for the end of the semester, I will be able to grade your work with the new UI features in place. And of course the old UI features still work, you just can't see them in the menu anymore. So we can go either way. So if you want to work with this and do your projects with 4.6 and learn the new UI stuff, then you can certainly do that. And I'm pretty fluent in it. I don't see the point in doing a session on it because they've already done a good job. There might be a few gotchas in there that I can show you, but if you want to tackle it, go figure out what's going on with it, that would be a good idea. And that's all I've got for you guys.